Good day everyone! I am Irma Jane Pagara. In this video, I will be justifying what I have achieved for the following 5 learning goal objectives. First, explain the definition of a group and identify as well as produce examples and non-examples. Second, prove the elementary properties of a group. Third, construct and or complete Cayley tables for finite groups. Fourth, use the elementary properties of a group in proving related propositions. And lastly, use technology to communicate solutions and proofs to whole class. So, let us start. So, in mathematics, a group is a set and an operation that combines any two elements of set to produce a third element of the set in such a way that the operation is associative. An identity element exists and every element has an inverse. These three axioms hold for number systems and many other mathematical structure. For example, the integers together with the addition operation form a group. The concept of a group and the axioms that define it were elaborated for handling in a unified way essential structural properties of every different mathematical entity such as numbers, geometric shapes, and polynomial roots. Because of the concept of group is ubiquitous in numerous areas both within and outside mathematics, some authors considered it as a central organizing principle of contemporary mathematics. Now, is it possible for a group to have two different identity elements? Well, suppose E sub 1 and E sub 2 are identity elements of some group G. Then E sub 1 times E sub 2 is equal to E sub 2 because E sub 1 is an identity element. And E sub 1 times E sub 2 is equal to E sub 1 because E sub 2 is an identity element. Therefore, E sub 1 is equal to E sub 2. This shows that in every group, there is exactly one identity element. Another one, can an element A in a group have two different inverses? Well, if A sub 1 and A sub 2 are both inverses of A, then A sub 1 times open parenthesis A times A sub 2 close parenthesis is equal to A sub 1 times E is equal to A sub 1. And open parenthesis A sub 1 times A close parenthesis times A sub 2 is equal to E times A sub 2 is equal to A sub 2. By associative law, A sub 1 times close and open parenthesis A times A sub 2 is equal to close and open parenthesis A times A sub 1 times A times A sub 2. Hence, A sub 1 is equal to A sub 2. This shows that in every group, each element has exactly one inverse. For an illustrative example, let's build the Cayley table for the cyclic group of order 3. That just means that it has 3 elements in the group. So although different symbols can be used, we will call the group elements 0, 1, and 2. And we will use the group operation of addition modulo 3. So this means that we add the element, but if we get a number higher than 2, we subtract 3 automatically. For example, 1 plus 2 is equal to 0. In this group, since 1 plus 2 gives 3, but then we subtract 3 to get 0. So here's the Cayley table for this group appearing here. To fill in the bottom row of the Cayley table, added modulo 3 to get the 2 plus 0 is equal to 2, and then 2 plus 1 is equal to 0, and 2 plus 2 is equal to 1. Filling in a Cayley table is easy as long as you know the group operation. Technology provides additional opportunities for learners to see and interact with mathematical concepts. Students can explore and make discoveries with games, simulations, and digital tools. Technologies such as mathematics software, scientific calculators, spreadsheets, and statistical packages have become commonplace in many classrooms. This is in sharp contrast to traditional mathematics classroom, which was dominated by pen and paper. So the use of technology serves as a motivation for teachers due to the positive outcomes achieved. Technology leads to teaching that is more effective, and this leads to better performance of the students. So that would be all. Thank you, and may God bless us all.